For 50 years, cosmic explosions known as gamma-ray bursts appeared for a few moments, then vanished forever. But recently, astronomers witnessed something entirely new, a burst that refused to fade, flashing repeatedly over the course of a day. This single event released more energy than our sun will in its entire 10 billion-year lifetime, challenging everything we thought we knew about the universe's most powerful blasts. This discovery, designated GRB 250702b, forces us to reconsider the physics of stellar death. The initial alert came on July 2nd from NASA's Fermi Gamma Ray Space Telescope, which detected not one, but 3 separate bursts from the same spot in the sky over several hours. This strange behavior prompted a worldwide astronomical investigation, revealing an even bigger surprise from the Einstein probe, a mission by the Chinese Academy of Sciences in collaboration with the European Space Agency. Data showed the source had been active almost a full day earlier. This orange dot, captured by the European Southern Observatory's Very Large Telescope, marks the location of an explosion that breaks all the rules.
What cosmic engine can power such a long-lasting, repeating cataclysm? How can an event that is supposed to be self-destructive happen again and again? And what does this tell us about the exotic objects lurking in the distant universe? Gamma-ray bursts, or GRBs, are the most energetic explosions known since the Big Bang. They are brilliant flashes of high-energy radiation that can outshine entire galaxies for a few brief moments. For decades, astronomers have sorted them into 2 main categories based on how long they last. Short bursts, lasting less than 2 seconds, are thought to be caused by the collision of 2 dense objects like neutron stars. Long bursts, which can last up to a few minutes, are believed to signal the death of a massive star as its core collapses into a black hole. In either case, the event is catastrophic, completely destroying its source. That's why the repeating nature of this new burst is so profoundly baffling to scientists.
The initial signals from space telescopes like Fermi and the Einstein probe gave a rough position, placing the burst in a crowded field of stars within our own Milky Way. This led many astronomers to initially believe it was a local event. To find its precise location, teams turned to one of the most powerful ground-based observatories on Earth, the European Southern Observatory's Very Large Telescope, or VLT, located in the Atacama Desert of Chile. The VLT's observations fundamentally changed the understanding of this event. Using its Hawk-Eye infrared camera, astronomers pinpointed the source not within our galaxy, but far beyond it, a finding later confirmed by the NASA ESA Hubble Space Telescope. The host galaxy is thought to be several billion light-years away, meaning the explosion was immensely more powerful than first imagined.
This event was unlike any of the thousands of gamma-ray bursts observed before. Not only did it repeat, but it lasted for about a day, which is 100 to 1,000 times longer than a typical GRB. This unprecedented behavior has sent theorists back to the drawing board, forcing them to explore scenarios that were once considered highly unlikely. The key to understanding GRB 250702b lies in its bizarre repetition and duration. The first alert on July 2nd from NASA's Fermi satellite registered 3 distinct outbursts over several hours. Archival data from the Einstein probe then revealed prior activity from nearly a day earlier, confirming this was not a one-off event. Pinpointing the source was a critical next step. The task fell to the Very Large Telescope in Chile. Its advanced Hawk-Eye instrument detected an extremely faint red point of light that faded over several days, confirming an extragalactic origin. This was later cemented by observations from the Hubble Space Telescope, which resolved the faint host galaxy. This distance is crucial. It implies the burst's energy output was staggering, far beyond what could be produced by phenomena within our own galaxy. The data collected has left scientists with a puzzle that challenges the foundations of GRB physics.
So, what could possibly cause such a strange explosion? Scientists are exploring a few highly unusual scenarios. One hypothesis suggests the collapse of a very massive star, perhaps 40 times the mass of our Sun, in a way never seen before. In this model, some process allows the central engine, likely a newly formed black hole, to be refueled, powering subsequent bursts. Another possibility involves a tidal disruption event, where a star is torn apart by the gravity of a black hole. But to explain the repeating nature and other properties of this particular burst, it would require a very unusual star being destroyed by an even more unusual black hole, specifically a long-sought-after intermediate mass black hole. This class of black hole, with a mass between 100 and 100,000 times that of the Sun, could potentially strip a star apart over multiple passes, creating the observed periodic flashes. Both of these potential explanations would represent a major first in astronomy.
This discovery reshapes our understanding of the most extreme events in the universe. It suggests there are stellar death processes and black hole interactions that we are only just beginning to imagine. The existence of a repeating, day-long gamma-ray burst opens a new category of cosmic explosions. This single event provides a new lens through which to study the physics of stellar collapse and the behavior of matter around black holes. Future missions and observatories will now be searching for more of these strange repeating transients.
Right now, astronomers are continuing to monitor the aftermath of the explosion. Teams are using powerful instruments like the VLT's X-shooter spectrograph and the James Webb Space Telescope to study the fading glow and the host galaxy. These observations will help them precisely measure the distance to the event, which is key to calculating its true energy and narrowing down the possible causes. In the near future, the hunt will be on for similar events. Observatories like the upcoming Extremely Large Telescope, also an ESO project in Chile, will have the sensitivity to detect even fainter and more distant versions of these repeating bursts. Looking further ahead, a larger sample of these events could reveal patterns that lead to a completely new understanding of the life and death of massive stars. It might even provide the first concrete evidence for intermediate mass black holes, a missing link in the cosmic family of black holes.
The universe has once again shown us that it is more imaginative than we are. An explosion that should have been a final, singular scream has become a repeating beacon from billions of light years away. The mystery of GRB 250702b is not just about solving a single cosmic puzzle, it's about opening a new door to understanding the most violent and energetic processes in the cosmos. As we continue to probe the skies, we're reminded that some of the biggest discoveries begin with a signal that simply refuses to follow the rules, much like the enigmatic fast radio bursts we've explored previously.